All right, I will start with one question. So I think it's really interesting to explore the privacy and utility trade-off, and one of the challenges I see is to assess the privacy level. So I see you're using membership inference attack. I'm wondering, does it matter what inference algorithm you were using, or different algorithm actually have pretty consistent results in terms of privacy level?
So we actually went for the membership inference attack since, again, as mentioned during my presentation, it's one of the most studied attacks in genomics as well as machine learning. But secondly, we could have gone for attribute inference, but because the way that genomic data is, it means that all the attributes are so correlated with each other that implementing that, the success of that attack seemed like a very naive hypothesis, considering how, the fact that all attributes are correlated to each other. It seemed like that's not the attack that we're looking for. And if we want to look for more interesting privacy threats, I think membership inference was the way to go for our case, hence why we chose this one. And also we went for the membership inference attack with only partial information available to the attacker, just to see what if. I think that also showcases the fact that attribute inference attacks would be possible just by the fact that with 0.05, which is 5% of the actual sequence, we could actually have quite a few cases when the membership inference attack was above the random guess baseline.
All right, so maybe I ask another one. So when I think about the utility side, I think one of the challenges, again, to select sort of a representative set of applications that are going to use this data. I'm curious, have you looked at those end-to-end applications using genome data, or current analysis is mostly focused on statistical analysis on the different aspects?
So not for this paper, we haven't looked more into depth at other ways because, first of all, this was one of the first papers that looked for synthetic data, at synthetic data from both utility and privacy. And our intuition was that that's the first step, the statistical analysis. If that doesn't work, is it worth actually going further with this? And if it's good, but the privacy is bad, which I've seen in some of the cases of the models analyzed, if the utility is too good, but there is no privacy, would it really be a use case for using synthetic genomic data just as a privacy preserving mechanism, as most people advocate, most companies and startups advocate the synthetic data as?
All right, thanks. That makes sense. So it's essentially, this paper is kind of showing there are way more problems to solve before we can use this, widely in practice.
Yes, pretty much.
One of the first papers and many to come.